In this video, I'll be teaching you guys how to find the composition of two binary relations. So we have R circ S, and this is a notation for a composition of binary relations. But what does this mean mathematically? Well, I'm going to show you the formal definition of a composition of binary relations right now, but throughout this entire video, I'm going to mostly be using intuition for you guys. Of course, I'm going to use the arrows. Arrows are very easy to understand in comparison to math for some people. But I think it's important to show the math as well, right? For those people that actually understand it well. So let's go ahead and write down the formal definition of this. ASB, BRC, then ATC. Let's call this relation T, okay? So what do we get out of a composition of relations? Well, out of a composition of relations, we get another relation. And let's call this T, and we'll draw the arrows right here for you guys while I'm solving this problem. But what does this stand for? This stands for ASB, which means that there is a relation A to B in S, right? A and B are related to each other in S, which we have here. B and C are related to each other in R, which we have here. So first things first, how do you draw the first arrow? Let's remove this T for space. How do you draw the first arrow? Well, if we look at the definition here, we have A, B, okay? What's an A, B, and S? Well, an A, B, and S is just 1, 2, right? A is 1, 2 is B, right? That's a relation in S. So let's write down 1, 2. All right? So with this 1, 2, what can we do? Well, we know that B is equal to 2 now. So let's look at B. B is 2 in R. So let's start off with looking at R. What is 2 connected to in R, right? What's the C for R, right? What's the C for 2 in R? Well, the C is 1 because 2 is connected to 1. 2 is also connected to itself via this arrow, and 2 is also connected to 4 via this arrow. So 2 is connected to 1, 2, and 4. Now, look at the last part of this definition. The last part of this definition is AC. And that's in our answer. In our answer, T, the composition, we have AC. Well, A is 1. We start off with 1, right? And C can be 1, 2, and 4. So what can we connect 1 to? We can connect 1 to 1, 1 to 2, and 1 to 4. So 1 to 1, 1 to 2, and 1 to 4. And do you kind of see what I did here? Look at this arrow. This arrow is from 1 to 2, right? So this is the arrow we used, 1 to 2, right? 1 to 2. So if you're a little lazy and you're more of a visual learner, okay? Maybe you're not lazy, okay? Let's not say that. Maybe you're more of a visual learner. You're not lazy, okay? Just draw an arrow from 1 to 2. Copy this arrow, copy whatever arrow you have here in S, and then just write it down in the other set or other relation. Now that you have that, trace where this arrow is going. Well, this arrow goes to 2, and this arrow goes back, right? But there's another arrow pointing back at 1. So what does this mean? Well, that means 1 is just simply related to itself, right? 1 starts off at 1 and then ends back up at 1. That's how we drew this arrow, right? 1 ends up at 2, and 2 ends up back at itself. So that means 1 goes to 2, which is this arrow right here. Well, what about this? We trace this arrow, and we follow another arrow. You go to 4, which means 1 is connected to 4, which is this arrow, right? And you could do it like that. You could do it just like that. You can just copy the arrow, whatever arrow you want, and then just draw in the other relation. It's a more of a visual way to think about it. All right, but we can keep using the definition as well. I'll probably use both throughout this video, but let's take a look at, let's look at this one. Let's choose this one next. So this one, remember what I said? We can copy this arrow and we can just draw it straight down into R. Well, 1 goes to 3, but 3 goes to nothing else. So what does this mean? That means there is no relation formed from this arrow. This relation right here gets nothing, okay? Since 3 doesn't go out to anywhere, we get nothing. So let's just skip past that, get our time, and let's put an X over the arrows we've already used. All right, what about 2 to 3? Oh, we can copy 2 to 3 here. Well, 3 goes to nowhere again, right? Since 3 goes nowhere, we can't really trace this arrow along another arrow anywhere. So, no relation. X this out. We already used this arrow. What about 2 to 2? Well, 2 to 2. Again, remember what I said? We can just redraw the arrow 2 to 2 on itself and trace where this arrow goes. So we start off at 2. We follow the blue arrow. And then we just follow one more yellow arrow here. Or just one more arrow that's actually an R, right? Because this blue one, it's not actually an R. It's just a copy of what we put from S into R. And it's temporary, of course, we'll remove it. It's not actually part of R. But it's a good way to think about it, to just trace. So we trace along our pseudo arrow, and we just follow one more arrow. That one more arrow goes straight back to 2. So what does that mean? That means we have a relation from 2 to 2, right? 2 starts off at itself and comes back to itself after transversing these 2 arrows. Okay, this blue arrow and this yellow arrow. So it goes back to 2. So what do? We draw an arrow from 2 to 2. All right, let's trace this out again. We follow this blue arrow, and then we pick one more arrow that comes out of 2. Well, this arrow comes out of 2. So we have something that starts at 2 and ends at 4. So what does that mean? We can draw a relation that starts at 2 and ends at 4. All right, we should follow this arrow and follow one more yellow arrow. What's the last yellow arrow we can have? It's this one, right? We've already used this one. We've already used this one. And there's no more arrows pointing out of 2. So we should go from 2 to 1, right? So this arrow goes from 2 to 1. And we trace this blue arrow, and we follow this yellow arrow as well. So what does this mean? That means there's a relation from 2 to 1 inside of our composition, which is called T. We can put a T up here. And let's see. Did we trace all the arrows that could be possible from this one? Well, we did, right? There's no more arrows coming out of 2, so let's go ahead and X this out, right? We've exhausted this one. All right, what about this? 3 to 3, right? So we should draw an arrow on 3, okay? And 3 to 3 in S also stands for 3 is equal to A and 3 is equal to B, right? Oh, my goodness, my allergies. Oh, my goodness. But we have A, S, B, okay? B is equal to 3 as well. Now, here's the thing. In R, right, in R as well, this arrow right here, if we follow this arrow, there's no other arrow that comes out of 3. There's no other one, right? In order for us to draw something in the composition, we need 2 arrows to trace. There's only one arrow here, which is the pseudo arrow that we drew, right? The fake arrow that we took from set S and drew it in R. So there's no other arrow coming out of 3. Again, that means there's no C value, right? This is the definition. There's no C value. There's nothing. There's nada for C. That means if there's nothing for C, we'll just have A and nothing for C. That makes no sense, right? So a relation has to have 2 values to relate to 2 things. But if we only have A and we have no C value, then there simply is no relation, right? Given by this definition. So this arrow right here gave us nothing again, right? Anything that leads to 3 seems to give us nothing. All right, this is the last one. All right, so we can copy this. Let's copy this and trace it to 4. All right, so we've copied this. We made a fake arrow to 4 in relation R. And it looks like nothing comes out of 4. Huh. Yep. Nothing is coming out of 4. So this is basically pointless as well, right? If we trace this arrow from 2 to 4, there's no other arrow that's coming out of 4 for us to keep following. So that means there's no C value in our definition. Therefore, we just draw nothing inside this composition. And we've used the last arrow in S. Now, one important thing to point out with this, and just saying we finished this problem already, okay? But one important thing to point out about this is that S is on the right side of our composition. Typically, when you're doing, I don't know, algebra, if you're doing addition or subtraction, whatever, you start from the left to right. But for compositions, you should start off on the right and end on the left. See how we started off with S, right? We copied the arrows from S and then moved them to R, right? Even though S is on the right side of this, okay? So keep that in mind. When you're doing compositions, you always start off on the right, all right? So you copy the arrows on the relation to the right and then move them to R rather rather than the other way around. Okay, so you start off with S and you end off with R. Alright, second problem. So this one, we're going to find the composition of S circ R. Now remember what I said previously. You always start off with the relation to the right. Okay, so now we're looking at R. Now we're duplicating the arrows in R and then moving them to S this time. Alright, so keep this in mind. Alright, if you didn't do this properly, if that was the first thing you thought of when you saw this problem, that's an important thing to know, because if you do the entire exact opposite way, oh god, you'll just get the entirely wrong answer. But so let's start off with R. Okay, so pick an arrow, any arrow, this arrow. Okay, so let's duplicate this arrow from 1 to 2 and draw it on S. So let's trace out this arrow. So let's go through this arrow first. Let's trace out the blue arrow, follow the blue arrow first, and then just follow any arrow that comes out of 2. Looks like this arrow comes out of 2 and it hits 4. Alright, what does that mean? That means there's a relation from 1 to 4 in the composition. So let's go ahead and draw that. 1 to 4. Alright, what's next? Well, again, we trace this arrow from 1 to 2, follow the blue arrow first, and then we trace it back with this arrow, right? Where does 2 go out? Well, 2 goes from 2 to 4, and 2 also goes from 2 to 1. So what does this mean? Well, that means that we go from 1 to 2 and 2 back to 1. So what's that composition? That composition is 1 to 1, right? So we went from 1 to 2, 1 to 2, and then we went back to 1, given this arrow. So this is our composition for 1. Sorry, for this arrow is done. All right, let's pick another arrow. Let's pick this one, okay? So from 2 to 2, let's copy this arrow, draw it on 2, and we follow 2. All right, so we follow this arrow, this blue arrow, our copied arrow first, and then we go ahead and follow any other arrow coming out of 2, and that is 4. So what does this mean? That means we have a relation from 2 to 4 in our composition. Let's follow this arrow again. It looks like this is another arrow that comes out of 2, which goes to 1. That means we start off at 2 and we ended off at 1. What does that mean? That means we have a relation from 2 to 1. So let's draw the arrow there. Okay. Looks like there's no more other arrows. There's no more other arrows coming out of 2. So we have used this guy up. All right. Another arrow. Why not? Let's pick this one. Okay. So let's duplicate this arrow onto from 4 to 3. Looks like nothing's coming out of 3. So what does that mean? Well, since we drew this arrow from 4 to 3, and there's no other arrows to follow out of 3, that also means that there's just simply no relation. So this arrow gave us nothing. Let's pick this one. Why not? Let's pick this one from 3 to 2. Let's copy the arrow from 3 to 2. All right. So from 3 to 2, what comes out of 2? Well, we can follow this. We can follow 3. Follow the blue arrow first. And then let's follow any other arrow that comes out of 2. Well, this one comes out of 2. So it goes from 3 and then ends at 4. What does that mean? That means there's a relation from 3 to 4. All right. How about this? You start off at 3 and we trace the arrow, right? The copied arrow first, and then we go ahead and trace any other arrow. Looks like there's another arrow coming out of 2 that lands at 1. What does that mean? Well, that means we start off at 3, ended off at 1. So there's a relation from 3 to 1. So we've used up this arrow. Let's use the other one. Heck, why not? Let's use this one. So from 2 to 3. So let's copy an arrow from 2 to 3. Now, again, if we trace an arrow from 2 to 3, nothing comes out of the 3. Man, I really hate 3. Even the last problem, nothing came out of the 3. But this right here is from 2 to 3. This hateful, spiteful 3 that no one wants to connect to. So what does that mean? That means that there's no relation. Okay? That means this arrow has formed no relation. All right, let's look at this one. Let's use this one. Let's copy the arrow from 3 to 1. Right? Let's copy this arrow. Copy this arrow from 3 to 1. Looks like there's 2 arrows that come out of 1. Right? So follow 3. Follow the copied arrow. And we can follow this arrow as well. And we come back to 1. So what does that mean? We start off at 3, we end off at 1. That means there's a binary relation from 3 to 1. But we already have that arrow. So what does that mean as well, right? What happens if we have a duplicate? Nothing. The arrow's already there. The relation's already there. We can completely ignore it. All right, how about this? We should follow 3 to 1. And there's another arrow coming out of 1. Back to 3, right? So this means that we start off at 3, and we trace this arrow, ended up back at 3. So that means there's a relation from 3 to 3. It looks like there's one more arrow to trace. Starts, go to 3 to 1, and we trace this arrow next, right? This arrow comes out of 1. We end up at 4. We started off at 3. We ended off at 4. That means there's a relation from 3 to 4. But we already have that arrow, so we don't have to copy it down again. Okay, 2 to 4. 2 to 4. Let's copy this arrow from 2 to 4. Right? Follow the arrow, the copied arrow, and follow any other arrows that come out of 4. It looks like this one is the only arrow that comes out of 4 and lands back at 4. So that means we have a relation, right? We start off at 2, we ended off at 4. That means we have a relation from 2 to 4 in the composition. But again, looks like we already have that arrow. And there's no other arrows coming out of 4, so we can remove all of that. Put an X on there, and looks like we've used all of the relations in R. We've exhausted all the relations in R. So that means this is the full composition.